folks, welcome to my YouTube channel. Good day, folks, welcome to my YouTube channel. If you're new here, welcome, and don't forget to subscribe, watch my videos till the end, like the video, leave a comment, and share with your friends and families. And if you are a returning subscriber, welcome back. Thank you so much for your support to continue doing the right thing. This is the Western Cape, September 2024. It's a question of momentum and energy, right? Let's look at this one. It says a pendulum bob with a mass of 3 kg is kept stationary. Very important that. So it's kept stationary. That means the initial velocity is 0 at a height of 1.2 meters above the surface. Now, if you look at the pendulum bob only with that, here's the pendulum bob is kept stationary, so that means here the initial velocity is 0, right? And then it has the height there, right? We know, guys, if the initial velocity is 0, that means the kinetic energy is 0. If the gravitational potential energy is not equal to 0, that means the gravitational potential energy is not equal to 0, right? Okay, now it says here in the statement, it is released and at its lowest point it collides with the block. So it is released and then it moves in that direction, right? And it collides with a what? With a block, right? With a block which is at rest on the frictionless surface, right? So this block, they said it's at rest, so that means its initial velocity is 0. Now bear in mind that the pendulum bob, as it goes down and approaches that, its velocity increases, right? It was 0, its velocity is increasing there, right, as it goes down there. So the pendulum bob is going to reach that. Okay, let's continue. It says in a frictionless surface, very important, it's frictionless surface as shown in the diagram below. Ignore all the effect of friction. So if that means it's a what? It's a closed system. This is a closed system or an isolated system, right? Okay, now they say state the principle of conservation of mechanical energy. They're asking you the principle of conservation of mechanical energy. That means you're going to use it. In an isolated system, a total mechanical energy remains what? Constant or conserved. I'm not going to write that. Stick to the exam guideline. Don't paraphrase it. 4.2. Use the energy principle, which is this energy principle. Use the energy principle only to calculate the speed of the pendulum bob just before it collides with the block. So the pendulum bob, it comes from that and it's released and it moves down, its speed is increasing, so they want its speed just before it collides, so that will be the velocity before collision. They want the velocity, that's the initial velocity, that will be the initial velocity before the collision. And then yeah, they want that, so we'll use the energy principle, which is the conservation of mechanical energy. Let me do it here. So we'll say EK plus EP, which is where before, is equal to the kinetic energy plus the gravitational potential energy after, right? So we know the EK is what? Is half mv square. That will be the initial velocity, right? And then plus the half, no, it's gonna be the EP, it's mgh, right, which is, that's the height initial, and then it's gonna be half mv squared, mv squared, that's the final velocity, and plus the mgh final, right? Okay, the kinetic energy initial, it is where it is here, This is before, and this will be after. Or we can say here the the mechanical energy at the top is equal to the mechanical energy here at the bottom, right? Okay, let's say top here or bottom, right? Okay, so the kinetic energy here, as I've mentioned, is going to be 0 plus the gravitational potential energy there. What is the mass of the bulb? It's 3, and then times what? 9.8. And then what is the height? The height is 1.2 times 1.2 equal, right? I hope I make sense there. And then when it gets here at the bottom, which is this is the final, this will be the initial, and this will be the final when it comes to these 2 points. So it's going to be half the mass is what is 3, and then the final velocity is the one that we want, and then plus the gravitational potential energy here. Since the height, when the bulb is here, the height is 0, that means the gravitational potential energy is going to be 0, right? And then guys, when you do the math, it's half times 3 is going to be 1.5 VF square equal to this. The answer of that is going to be 3 times 9.8 times 1.2, and then we divide by 1.5, we divide by 1.5, and then we put the square root of that. So the V final, which is this velocity here, it's going to be 4,885 meter per second. So this is the velocity that it gets just before it collides with this block, right? So this velocity in this case here is going to be the initial, but it's the final when it comes to when we start from there to there. This is the initial and this is the final, but in terms of collision, this will be the initial, right? Right, let's continue with the question. I hope that makes sense. After collision, the pendulum bob has a velocity of 1.8. This is the case after collision. So this is the before collision. This is the velocity before collision. So this is the V final, right? This is gonna be the V initial when it comes to collision, right? Okay, now it says, and the block moves up a frictionless ramp until it reaches the maximum height as shown below. So this block, it's hit by this, and then the velocity after is going to be that, and then it has its velocity while it moves up there, right? And then we're going to assume when it reaches that point, as it moves in the frictionless surface, it reaches the final velocity of what? Of 0, right? The final velocity of 0. Okay, let's leave that. It says assume no loss of mechanical energy occurs during this. Now 4.3, it says state the principle of conservation of linear momentum, right? The total linear momentum remains constant in an isolated system. Exam guideline, guys, when it comes to that. 4.4, it says calculate the magnitude of the velocity of the block just after collision. They want the magnitude of the block just after collision when it's hit by this. When it's hit by this, there will be a velocity there. Let's say it's here. They wanted the final velocity after collision, not this one, right? This velocity, it's when it gets to the top, when it gets to this height, it rests here. Alright, so they ask you here in 4.3 the conservation of linear momentum. That means you're going to use the momentum, the conservation of linear momentum. You say the total momentum before is equal to the total momentum after, right? Okay, now there is the mass, which is the momentum of the bob. So it's gonna be mass of the pendulum bob. Let's say it's the P for pendulum, and initial, P initial, plus this is the mass of the block and the initial velocity of the block, right? And then after collision, it's the mass, they're not combined after collision, it's the mass of the pendulum times by the final velocity of the pendulum plus the piece pendulum, and mass for the block times by the final velocity of the block, right? So let's look at the pendulum. What is the mass of the pendulum? It is what? 3, right? And what is the velocity before collision of the pendulum? The velocity before collision is this one, before it collides, which is this one. It's the 485. So it's 4,85, right? Plus. And then we are going to the block now. The block before collision, it was what? At rest here. So the velocity is 0. That means the momentum is what? Is 0. Alright, we're going to the pendulum again. It's 3. What is the final velocity, which is the velocity after collision of the pendulum? It's 1.8. So this is 1.8, and plus the mass of the block, it's what? The mass of the block, what is the mass of the block? It's 1 kg. It's 1 kg. And then, as I've mentioned, that we assume that is going to be at rest, even though we're not told in the statement. It's going to be at rest there. So the velocity there is going to be 0, right? The velocity is going to be 0 there. One thing, what are we looking for? I'm making a mistake here. What is the question? It says calculate the magnitude of the velocity of the block just after collision. So guys, we are not talking about this, right? We are talking just after collision, after its heat, just after its heat here. So it's gonna be this velocity. This is the velocity that we are looking for. Made a mistake, right? We're not talking about this, guys. This velocity that is 0 there. We're talking just after collision, because it's going to be hit by the pendulum and then it moves. So we want that velocity. So guys, your maths here, it's going to be it's 1 times VB. So it's going to be V velocity of the block, which is the final velocity, and then we'll take this to this side. So the answer, it's going to be 9,15 meter per second. And what is the direction of the block after it's just hit by this one? It's going to go in that direction to the right, as we can see, right? As we can see, it moves up in an incline. That means it moves to the right. 4.4, it says, this is 4.4, this is 4.4, 4.5. Calculated the height h reached by the block. So we wanted this height. As I've mentioned, this is going to be final velocity 0. We wanted this height, right, reached by the block. Guys, this is a closed system, as it was mentioned, so no external forces. So what we can use, so it's 4.5. that means we can use the conservation of mechanical energy, or we can use the work done by non-conservative force, which is the work done by non-conservative force is equal to change in EK plus in change in EP, right? So here, what are we going to do? The work done by non-conservative force, since this is a what? It's a closed, what am I doing? It's a closed system. So since it's a closed system, that means the work done by non-conservative force is 0. No external forces, no non-conservative forces. So we're going to put 0 there. And we're going to say half mv final square minus mv initial square plus mgh final minus mgh initial. And then we have a 0 there. We substitute. So we are looking for the height that is reached by the block. What is the mass of the block? Is what? Is 1. And then what is the final velocity of the block? The final velocity when it reaches here, the block, it has the initial velocity now. The one we just calculated is 9,15. 9,15, 9,15, and then this is the initial, the velocity that we calculated, that is just after collision, it's initial, and then the final is 0 because it's going to rest there at height h. So it's going to be 0 square minus the initial is 9,15 square. Don't forget to square, guys, plus, and the mass is what? It's 1 times 9.8, and then the height final, that's the one that we want. The height final is h, and the height initial, it started from the height initial. This is the height initial, and this is the what? The height final. So the height initial is going to be what? 0, right? I hope I make sense by that, guys. You can send a comment if there's anything that you do not understand. So guys, and this is the math. You punch this in the calculator and then you get your answer, and then this. So you have your 9.8 h, which is this, and then you take that to the other side, and then it's gonna be half times 0 is gonna be 0, and half times this is gonna be whatever the answer is. So whatever the answer is, and then we divide by what? By 9.8. You divide by 9.8, and then your height, it's gonna be 4,27 meters. So that means this height is 4,27 meters. Guys, I hope I make sense. Cheers, bye.